Hi, Professor.
Hey, yes, yeah, just feel free to switch on your cameras, all of you guys. We'll get started when everybody's here. Feel free to ask any questions, okay? As people are joining, you should just you should take this time as people are joining to basically small talk. It is strike up conversations with your classmates and ask them what they've been up to. Or if you have any questions about the class itself, that's also a great thing to ask. Oh, no, hang on. Yeah, okay. And yeah, well, people are, Josh is here too. That's great. Yeah, everyone should switch on your cameras. And Caitlin, is Caitlin here? Caitlin, yeah. Hey, all right, okay. Caitlin was a student from last quarter, CS2A. She's done with CS2A, and she is very interested in the subject and excited about, bitten by the joy of finding things out here, and she wants to help also anyone. So who Josh, Caitlin, me. I think also you can just go to the STEM Center and there may be tutors there too. But the three of us are kind of there for you. Okay. Do you have any questions? Otherwise, we will essentially go into class. And as you know, today I thought we'll talk about data representation. The last class we talked about data representation. Really meaning that and it is so don't start programming yet, because once you start programming, you'll get drawn into it, and then data representation will take a backseat, and you'll probably not even pick up the details of data representation even after finishing this class. You finish CS2A, but you don't know about data representation. It's entirely possible, because once you get on to questing, you'll just be drawn to the more programming kind of things. That is usually what happens to most people, okay? Programming, and so the theory tends to take a backseat. So the opportunity to master the theory when programming hasn't crept in, this is it. And so you should take full advantage of that. And you can talk to Josh, Caitlin, and all of these other people who've done it. Pretty sure they'll all tell you how important that week's topic is, this topic about data representation, because it will, it'll be even more important when you do CS2B, because there, some of the quests you do require an understanding of how the data is stored in terms of bits, individual bits, right? So you have something and you have, all right, so it's a sequence of bits that you need to manipulate in memory. So you'll have to do that in CS2B. But in order to do that, you need to be utterly comfortable with the idea of bits and how to represent data. Essentially, that's where we're going. Okay, yeah. So that's all. So as far as the data representation part goes, anyone can suggest any problem they want to work on, and it does not have to be them. Okay, so for example, Tugzoyan. How do you pronounce your name? Tugzoyan? Tugzoyan?
Tugzoyan, yeah.
Tugzoyan, right? So maybe she says, well, you know what? I want to know more about octal to binary or something like that. Okay. However, I don't want to be the person doing it. So she could say, that's what I want to find out. And call out someone too. Maybe say, hey, Lon, can you, or Ian, can you, can you take the screen and can we all work through a problem so that I get an understanding? And I think that'll actually work out very nicely, because there'll be multiple parties involved in this. So Toxorin would actually come up with the idea of what to work on, of all the topics, that you pick one that is confusing to you, which is a very high likelihood of being, if it's confusing to you, chances are it's going to be confusing to other people too, at least one other person, most very high, very likely. So you pick one and say, I want to do this. And if you are up to it, you can say, I want to do it and I'll share my screen. That's fine. Okay, fantastic. You can do that too. And towards the later part of the quarter, many people will actually want to do that. Okay, say, I want to code, I'll do this. especially the people who've got practice doing that earlier in the quarter. Okay, so if you're kind of shying away from this, say, and thinking, well, you know what, let the other people do, I'll just watch. Then I think later in the quarter too, you won't be able to. It'll get harder. Yeah, I think that's what it is. Okay, it's harder to get on board a moving train. So if you wait until after 4 or 5 weeks to actually take the screen and do everything in front of someone else, it will be not just, you know, incrementally harder. It'll be, you know, 3 times harder, because the problems are faster, harder, and things are moving faster too. So if it's moving faster, you feel more stressed. All right, I got to stay on the tips of my toes, or I'm going to fall off and make a fool of myself. At the end of the day, it totally does not matter if you make a fool of yourself. But students are, you know, unnecessarily concerned about that, and that's what they feel stressed out about all the time. All the time when people are doing stuff in public, that's what they are stressed out about. You know, stage fear, anxiety, and all of that is, you know, oh my gosh, what are other people going to think of me? And that should be the least of your worries ever. And so, you know, so what? I'm going to do it. That's what I do, right? And so you should be absolutely free to, you know, jump in and say, all right, I want to code, or Tuxoin, or the person who came up with the problem will actually nominate someone. All right, and say, hey, Rohit, can you share the screen? Now, the important thing is, Rohit shouldn't really say no, because he does not have to participate in any capacity other than just typing whatever is being spoken in the ether sphere, right? Because all he's going to do is just share the screen and open Notepad or, you know, online GDB, and he's saying, and a clear screen, and he's going to say, all right, Tuxoin, I'm going to try this. What is this problem that you want to work on? And then type out the question, and then someone else is going to take over. Okay, if nobody, Caitlin, Josh, me, right? So we're all there as backup to essentially jump in. But at the same time, I think we're all aware that we don't want to eat your lunch, because this is a great opportunity. And you won't get opportunities like that, okay? Later, and people may think, you know, well, I'll do something like this later. You never know. And this is a fantastic opportunity for you to actually code in front of other people. It is like public speaking, okay? You have to master that skill. And you only master a skill when you get really good at it. Because until you're good at something, you're not confident. Something could go wrong. Yes? And so the best way to master stage fear is to actually keep practicing again and again and again, right? So you know the notes inside out. You can sing the whole song backwards, right? That kind of thing. So do it again and again. You can do it in your sleep, practice, and then you could just march on to any stage, and you know, and you can perform with your eyes closed. And that's exactly the way it is in programming too. Okay, keep practicing, 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 and pretty soon it doesn't matter if, you know, if you are being watched by, you know, the president of the universe or your CS2A classmates, right? You're just going to do it because it is fun and you want to do it. Okay, so that is where we're all going. We're all a friendly bunch of people here. Okay, totally friendly bunch. There's nothing absolutely to be afraid of. And so you should totally take advantage of this great opportunity, right? And I say this, you know, I'm saying this increasingly, you know, during these quarters. Hey, Tuxoin, are you actually in a car? Are you driving? Are you?
I'm not driving, but I'm in a car.
Okay, all right. Obviously, you can't share the screen now. All right. All right. So you will nominate someone, okay, and then that person will have. But before you nominate someone, you got to say, this is a problem I'm confused about. Well, it's not you. You know, you just came up as an example. Whoever it is, say, this is a problem, and I'm confused about, and I'd like myself to code, or I'd like someone else. Okay, it shouldn't be a tutor or Caitlin or me. You should just nominate someone. Just pick someone at random. And especially someone who hasn't got their camera on, okay? Because that is a good way for us to also tell that everybody's engaged. Because at the end of the day, you're all going to help yourself. You know, I'm just basically trying to ease myself out of your way as much as possible. Because, you know, yeah, all right. So ultimately, this is just going to be a student-guided community for students by the students, okay? Because, you know, you can't expect me to keep running it forever and ever, right? So at some point, you guys have had to take over these things, and I think it is a great community worth preserving. So you just jump in and just completely manage it by yourselves, okay? And this would be a great way for you to get started in CS2A. And there are people who've done it before, right? So Josh and Caitlin, they can jump on the Reddit and ask anyone in CS2B or CS2C to just DM them. Say, hey, I'm trying to do this. What do you think? Right? Or, what is your recommendation in this particular? And I'm pretty sure everyone who has, done this class will be happy to help their junior students. Okay. In fact, speaking of that, there is one of my students from 4 years ago. The first time after I made a questing, and I said, I'm going to try it out on my poor CS2A students. And Fred was the first batch of students to actually use questing, I think. All right. So you got to go back on the Reddit and find out. But I think he was either the first or second batch. And then after he finished CS2A, 2B, and 2C, you can actually see his track record through all of the quests, starting from Tiger all the way to Mouse. He went to Georgia Tech and did his master's. That's what his email said. Okay, he completed his master's in computer science at Georgia Tech, which I believe is a popular destination for lots of our students. Okay, because many students I talk to, they say, "Well, what is your plan? I want to go to this Georgia Tech program." So I think they have a very popular program. So this is a fantastic opportunity. And he actually reached out to me and he said, hey, how is it going with your class? And it is absolutely fantastic that he's coming back to talk to you guys. And hopefully, by the time you guys are graduating, I'll be retired. But certainly you can reach out on the Reddit. Okay. I'm pretty sure maybe it'll be a student-run community. You can say, hey, I graduated this thing in 2024, and now it's 2028, and things are completely different. But I just wanted to say, hey, how are you guys doing? How are you learning computer science? Are you still grinding in these quests night and day, just like I did? Okay, and chances are they will be. Okay, even though AI can do a lot of things, it is like it's a puzzle. Someone else can solve the puzzle for you. But what's so fun in having someone else solve the puzzle? It is a puzzle that has been solved. If you open your math textbook, at the end of each chapter, how many problems do you have, right? 200 problems at the end of each chapter, right? And it's not like they're all open problems. Most of these problems are actually, they have nice, instructive, and beautiful solutions. And the idea is not to say, well, well, since these solutions already exist, I'm not going to work on these problems. No. The whole idea with all these problems is that you will work through as many of them as needed. Okay, they're all there for you. And unfortunately, lots of students actually skip I'll just do the odd numbered ones or things like that. Because the teacher basically says, if you really absolutely have to not do everything, here's the ones I absolutely minimum recommend for you to work on. So he'll or she will say, right, 1, 7, 18, 24, and change it every quarter for different students. And you just work on those. But that is basically for a student who says, I don't have any time because I'm doing like a zillion other things and math is on the fringe of my interests. Okay, then they say, all right, do at least these. But if you're really, really interested in the subject, you have to go through every single one of those problems because they've been put together, right? Especially the old books, the facts, not old books, but the ones that we use for education today in high school, the math books, they're so fat. As they have these problems, even computer science, right? All these problems, saying, right, implement a simple program. Don't skip through these because even though it's a simple program, in the process of doing a simple program, you'll actually discover something. Okay, some small thing that you would trip you up. But because it's a simple program, it didn't trip you up fatally. And that is the whole idea with working through these simple programs. And then you build on to the bigger programs. But by the time you're working on the bigger programs, you would have mastered the art of not tripping on small issues, right? So you'll actually be reasonably safe. Yeah, that is where you have the confidence and say, well, I can just do it online. It doesn't matter who's watching because I know, it is absolutely easy and easy to do. All right. So anyway, enough of a spiel. 6:15. See, it's 15 minutes. I've been talking for 15 minutes. All right. All right. Okay. So this is my plan for today. Okay. Next week onwards, we'll start coding. Hey, by the way, I totally forgot. Yeah, the Fred announcement. He's coming Tuesday. All right, next Tuesday. I sent the URL, but the Zoom link. It's and in the announcements. Check and click on it. Next Tuesday's class. After class, which will end at 7:30. Get out of this meeting and click on the other Zoom link that I sent, and so you'll come back essentially into the Zoom, but it'll be the meeting with Fred, and he'll be there, and I won't be there for the whole meeting. Essentially, I just want to introduce you guys. And then I'll take off. I want to say hi to Fred also. So I'll take off, and then you can just be frank and ask him. It will be recorded, but I don't think I'm going to share it by default. Okay, it'll be there for someone who can absolutely not make the meeting but is interested and can't reach Fred or something like that. So I'll be happy to. But your best bet is to actually attend the meeting and ask Fred. There will be other people who may reach out too, because Fred has a number of classmates he was working with, and he might tell. I'll tell Fred to tell the other classmates too. Anyone is welcome to come back and talk to our current batch of students. It's a great deal of fun, right? Because that gives you a great deal more energy to work through some of these challenging quests. Because these people have been there and done it, and nobody actually died doing this. So you'll feel more enthusiastic. That is my feeling. Okay. All right. Okay. Hey, Yang, you said you're going to change your name on Zoom. You didn't do that? And where's Vin? And Vin is Mike or Mark? I don't know, one of them. Eva,
Sorry,
yeah. So sorry. Yeah.
sorry, I didn't actually click on the link. I think it's different from my Zoom account. I will just
Okay.
change
Well,
it.
I may just call you Yang then. Okay. Because
Okay.
all right. Okay. Ava, you have your hand up. You have a question?
Yeah, I wanted to ask if we have a concept question. Do you want us to ask through Reddit or in class for if I want you to explain further?
All right.
Okay.
Totally. Very fantastic. Okay. If you have a concept question, you can totally ask during class. And I will be
Okay.
happy to explain. No, two options. Okay. But I'm saying if it is not urgent, ask on the Reddit first, because that is your best.
Okay.
You get participation points. You get something in your log, okay, in your star log, whatever it is, the dating, and you ask a question. You give someone else an opportunity to think about the problem and answer it, and someone else who has the same concept question will also get a chance to get clarified there, and it'll be on record permanently. They don't have to scrub through the video in YouTube, especially since after it's all gone, right? It's all on Zoom, so it'll be gone. So please try Reddit if it's and after the Reddit explanations, if you still feel that you or others can benefit from me explaining it in my usual more verbose way, and it takes more time because I use all these weird examples and crazy things, and I digress on a tangent and all. But most of the time, what you'll find is that the Reddit explanation is fantastic and to the dot, because other students have also thought about the exact same thing. And so they know what is needed. Whereas, professors, even your parents, they'll always try to overcompensate a bit because, we'd rather give you more help than less. But technically, to give you less help until, if it's not going to kill you, go ahead and do it anyway. Okay, because you need to do it. But I think professors usually overcompensate. Okay, they'll make it easier for students. And they may give you lots of information that you don't need, and at this point in your life anyway. Or in your career as a software engineer, maybe you don't need to know about certain details that I might say, well, you know what, I just taught my CS2C students, my 2A students are all going to learn about it in 2C when it's more, So your best bet always, and that is the reason I'm also pushing this community thing. It's not like I'm lazy. I want to just, leave this everything to you guys. And you guys take care of each other. No, I'm always going to be there, right? I'll be there, in addition to Caitlin and some other people may also join, right? People from 2B and other sections may also join to help. I'll be there. But I think that it is time that it may actually be worthwhile turning this boat into a self-sustaining vehicle so that I don't have to be around for it to just continue by people supporting each other. Because I think it's valuable. Lots of people are actually learning, and if you look at the Reddit, you'll see that, very early on when Fred was a student, I used to chime in a lot in the Reddit. right? So when people ask a question, I'll chime in and say, this is the answer, this is the answer, right? And I think about a couple of years ago, maybe, or 1 year ago, I just stopped or toned down or stopped doing this. And miraculously, it just emerged from out of nowhere. The students started helping each other, and it was much better than I was saying, lots of things. So people are actually helping each other. But in the early stages, I had to, push a little bit more, but students are actually helping each other now without me even asking. And they're doing some really cool things. Last quarter, they, talked to Josh and Caitlin. They actually did some really, really cool stuff. And then speaking of that, something actually came out of what they did in class last quarter. It is called the Grady game. Okay, it's actually a game that these guys in CS2A decided to turn into a conference presentation at RSLS, which is coming up in in next month. So they're doing an experiment, and you have to play a game, and there's no personal information collector or anything, and it'll tell you whether you're a nerd or a bird, or how much of a nerd and how much of a bird you are. Okay, actually fun. It's like 10 minutes. Yeah, I mean, 1 minute of your time, essentially. Just play it. And when you play it, it actually they collect some data on the number of tries it took a random person and so on and so forth, and use that to build up some statistics that are interesting. Which everybody will have access to at the conference. So please go ahead and try it. And in fact, there is also we at one time, I think we also played a tournament of 2 teams, 2 innings and 2 teams, or things like that. Everybody gets to play, and it's actually fun. So yeah, please do that. Okay, I promised myself I would announce this in class today. I almost forgot. Okay, and Caitlin, when I saw Caitlin, I remembered. Hey, there's something I got to do, because Caitlin is like the police person of that project. Okay, he keeps tabs on everyone. And right, okay, thank you. It's all right. Is anything else do you want to do, or does someone basically want to step in and say, I want to work through a base conversion, or I want to understand how 2's complement works. Okay, can we convert a number into 2's complement notation? Meaning, what is the 2's complement representation of a negative number? Like whatever the number was, 152. Well, pick a different number, 172, 175. Pick another number and say, well, hey, I want to represent 175 in binary, which you can do with the division stuff. But I want to find the 2's complement version of negative 175, right? And then you can try to do that conversion. And maybe you start with a blank slate, and someone will say, hey, this is what you want to do. Maybe work through an example in base 10. That's 9's complement. Josh or me or Caitlin, someone will help you do that if you want. It is in module 0 also, but it's always fun to work through one of those in class. I will be happy to do that. But someone has to pop the question first and say, hey, can someone share the screen, or can I share the screen, meaning you, the person who says that, and work through a problem, right? And it's going to be Notepad. Set the font to something big, and then we'll just go from there. Okay. All right. So I just want to hand over to you guys if you don't have any questions for me. Hey, Kunlu, hey, Kunlu, you just joined class, right? You weren't here last class. Yes? Are you here?
Yes, I'm not here last class, I think.
Yeah. All right. So yeah, you may have missed this. You got to keep your camera on. Zara, you also. I don't remember seeing you last class. Okay. Everybody's got to have the camera on. Salami, right? This is Salami. Is that your first name? Kahya. Salami. I don't know. You didn't respond last time either. Sophia and Josh. I think I saw Josh a little while ago. All right. Sophia, I haven't seen you. In case you're here, you should at least be vocal. You should be talking, or you should have your camera on. Otherwise, you'll be, asked by someone to say, hey, share your screen, Sophia. Can you be the typist for this problem I'm interested in solving? Okay. So all of you guys. Okay. If you don't have any questions for me, I would basically like to turn it over to you guys and say, can I want to understand this concept better. And it doesn't have to be 2's complement. You don't have to go all the way. Of course, you have to learn about these before you go on to questing, because once you start, like I said before, right, so you got to do that. And you got to learn this for the data representation quiz that's due tomorrow. So you can say, I want to work through a 2's complement, or you can say, I'm still not comfortable with base conversions. Let's do one of those first and then goes to 2's complement. Perfectly fine. But the thing is, one of you has to ask a question and say, hey, let's work through a problem, right? So basically, what I'm saying is no idle airwaves here, right? Just keep talking. Just keep talking and say, I want to know how to do this. I want to know how to do this. Okay, and then take it from there. And I'll be here. I'll just turn the laptop around, so I'm not even in your face. Okay, so I'll turn the laptop around, so you're looking in that direction. I'll be over here, and then you guys can continue to. Unless you want me to, when you say, hey, prof, come back, we're stuck here. Or can you give us an example in, using, well, we're trying to do two's complement. Can you describe it using tens complement? Okay, the students usually love that. But someone else can do that too, right? Caitlin or Josh, anyone who knows what tens complement is and how it relates to two's complement can walk you through that. So it's not, I don't think it's like a story that goes old. This is interesting stories will go old after time, but this is an exercise that students work through, and it's actually fun. So we can do that any number of times, any number of quarters, where it'll be fun. So when you get to that, just compliment. But until then, if you have any other questions and you need to ask, go ahead. Okay. If you don't have any questions for me, I'm just going to turn the laptop around. So, I'm not in your face. So are you guys ready to roll, essentially? Meaning that one of you has to say, here, in module 0, I'm trying to understand this. Can someone tell me what it is? You can even say, can someone tell me what this, base 27 thing is? I don't understand what base 27 is. And someone could say, hey, I'll tell you what base 27 is, and then share the screen. They could share their own screen and say, hey, this is what base 27 is. Take your, opportunity to explain this to someone else. You don't have to work through a problem at all. Right? So maybe Kunlu says, hey, what is this octal to hexadecimal conversion? You guys did this last class. Can someone go through that really quickly before we start an actual problem? And then Ian might say, yeah, sure. Okay, I can do that. Well, you're not walking today, right? Yes, last time you were on a walk. Yeah, so Ian might say, yeah, I can, and it'll also be a good refresher. Okay, so even if you think that you understand base conversions, just working through that. Like they say in music, right? When you start singing, you always do some warm-up exercises first to make sure that everything is fluid. And then you go to the harder challenges just to make sure that everything is greased and moving. So it's better to do something that is relatively simple just to get into the intellectual groove, and then work on two's complement and other things. How about that? Okay. All right. So first, if we do 10 minutes of some base conversions, someone who still does not understand base conversions is going to ask, hey, can someone describe to me how to do a conversion of one base to another? Okay. And one of you is just going to volunteer and say, hey, I'm going to do it. Okay. I'll share my screen. And you're going to talk to that other person. It's, and then it's just like you just pretend you're the professor. Okay. Except you don't get paid. All right. So you just pretend you're the professor, and you're going to talk them through this. And say, and you can ask, do you understand? Do you understand? And at that point, when you're describing it, not only the person who asked the original question, but others can also chime in and say, hey, I don't understand that part. Okay. And that is the way to strike up a conversation, I think. All right. Which will basically illuminate the whole concept, because you can be sure that in understanding a concept, you manage to find as many questions as possible to ask about it, because nobody can look at it from all possible perspectives. There might be some things they missed or didn't ask, but in a group like this, you're asking questions in this area, someone else might ask a question in that area. So by just looking and paying attention to what everybody is doing, you'll actually get a very good intuition about the problem space, right? The topology of the problem space, in how many different ways you can view the problem, right? Which is usually the number of different ways you can find solutions to, different kinds of solutions. All right. Okay. Hey, yeah, all right. Jesus, Jesus or Jesus, how do you pronounce your name?
Jesus.
Jesus, okay, all right. Hey, you're at an angle, like, 135 degrees or something. Are you like a vertical, or are you camera off center or something like that? Oh, well, okay. See the the wall thing behind you. That's vertical. Okay. You were at an angle before, like you were almost lying down or something. That's okay. We actually had students when I used to teach an 8 a.m. class before I switched to this timing. And during that time, we had students who are still in bed. Okay. And then their mom or dad would wake them up and hand in this laptop with Zoom logged in or something like that. And they're doing the class. under their bed covers, with the laptop in front. So we've had students like that too in the past. That was 8 a.m. classes. All right, in winter. Okay, everybody okay? No question for me? Yeah? Okay, now take it away. The only thing that there shouldn't be is silence. You got to be asking questions, and someone has got to be answering or helping out. Okay? Is that okay? Great.
Great. I have a question about the syllabus quiz, if you can answer those.
Yeah, sure. Go ahead, Richard. Yeah.
It's the question about if you don't participate in the class, what is the minimum grade or grades that
Yeah,
you?
okay. I thought I took that question out. Don't worry about it, okay? Everybody, if you got that question, you get a point reinstated for that. I had to recalculate everything now because I changed the grading scale after that, or the rubric after that, but I didn't change that question, so it's kind of messed up. Let me know, and ultimately, the syllabus quiz is there is just to make sure that everybody reads the syllabus. Lots of students just get into the class and they have no idea what they're getting into. And so, in fact, even other classes, I speak to the professors, they all have a challenge in actually getting students to read the syllabus. And so this way, at least it seems to work because everybody actually does read the syllabus. It's really cool. Are there any other questions for me? Okay. All right. All right. So best of luck coding. Not coding, working these problems. Okay. I'm looking forward to hearing lots and lots of conversations amongst you guys. Okay, right now.
I guess I can go ahead and ask a question. Does anyone kind of know how to do a base conversion from like, say, octal to hexadecimal, but without going to like base 10 first or vice versa, that kind of thing?
Could you repeat the question? You're trying to
Yeah,
go from a base to a base without going to base 10 in the middle.
right.
You could do arithmetic in the base that you start with, or you can just I find it easier just to use base 10 in the middle because I have a hard time doing math in binary, but if you feel like you're up to it, that is absolutely possible.
Yeah, that's fair. Thank you.
Oh, hi. One of the thing I noticed was like from the data representation saying talks about how like base 16 to base 2, you could just read it off the bytes. I'm not sure the similar thing will happen with base 8 and base 16 though.
Could you repeat that, the last part of that?
Like because how 8 is like half of 16 if you do that as a base, because I saw how like from 16 to binary you could read off just the just interpret each letter or number as the corresponding binary or something. So I don't know if that also true with base 8, but instead you just do it less.
Can you show an example of what you are talking about?
Yeah, I'm just not sure because I have some notes from the data representation saying would you give me a second?
Yeah.
I think I understand what he's saying. Because in like base 16 and like in binary, if you have 4 binary numbers, that's 16. So for every single hexadecimal digit, that's 4 bytes. And it's like once you know the pattern, it's pretty easy to convert binary to hexadecimal or hexadecimal to binary without stopping in decimal. So I think he's asking if there's a way for 8, since 8 is also half of 16, have a similar type of pattern.
Yeah, I agree
Is
with
that
that.
what you're trying to say?
Yeah, I think the example was like hex for 0x02C9. And if you look at 02 as just 2, which is 0010, C, which is 12. So that's 1100 and 9 being 1001. So you can just read off the pattern. So I'm pretty sure there's like a similar pattern for base A and 16. Just get used to it.
Yeah. So like if you just think about it, so a hexadecimal number is max of 16, and the octal number is max 8. Well, max 15, max 7.
So
So
would that kind
an
of mean,
octal number,
sorry, go ahead.
wait, this
You guys can work
like
through.
an octal number.
I think work through an example. Someone should work through an example, and it will be so much better. If you want me to talk you through the example, I will be happy to. But otherwise, rather than try to explain it verbally, try to work through an example. Someone share the screen and work through a transformation of one of these bases.
Anyone want to share their screen?
I guess he's asking you guys, but yeah, it's okay with me. You should, totally go ahead and share your screen, right? Anyone should feel free to share their screen and say, well, I want to try to see if we can convert this, and then people will jump in and say, hey, let's do this. This is the next step, and so on. So who wants to share the screen?
I could do it.
Go for it, okay? Go for
Okay.
it. All right.
I
And
just let me figure it out. Sorry, I think it's the first.
yeah, while he's getting ready, you guys should continue with the discussion or ask other questions if you want. Okay. Yeah. So the airwaves are still occupied.
I'm not sure if it could, because it's the first time I think I share a screen on Zoom. I should figure out some details.
Oh, you can't share the screen? Okay, well,
Yeah,
you figure it out. Maybe someone else can share this time.
yeah.
Someone else wants to share? Rohit, do you want to share today? Why are you also reluctant to share? Okay, there's absolutely nothing to feel concerned about. You can ask people who've done it before, right? They are in this class. It will actually be a great deal of fun. That is really what you're paying for. Because other than that, it's the same as watching YouTube videos. If you don't get an opportunity to code, it's like watching a video of someone riding a roller coaster than doing it yourself.
I can share my screen. I just didn't finish reviewing the second part of the reading yet.
Don't worry. Yeah, Ava, yeah, is that Ava?
Okay.
Yeah, Ava, yeah.
Yeah.
Go ahead, share your screen.
Okay.
You don't have to, but yeah, like Ava's concern was that she hasn't read the rest of the document. Even if you haven't read any of the document, you should just feel free to share, because the fact that you're sharing does not mean that you're the one who has to also solve it. You say, hey, I'm still trying to figure this out. This is the problem that I want to work on, and someone else will basically jump in.
Okay, one sec.
Okay, I'm sharing. This is Richard Kramer.
Thank you, Richard. Okay, and you can just type out the question up there and say, well, let's try and.
So one thing that I think Josh was saying is earlier was about the hexadecimal to say binary. Let's just look at hexadecimal A62C. If you break that out, A is 1010 in binary. 6 is 0110. 2 is 0010. Wow, I picked even numbers. Looks like C equals BC 1 1. That's C 8 9 10 11 12 0 0. So if we take that in binary, that's 1 0 1 0 0 1 1 0 0. Sorry about that. I'm gonna put a space in here so that I keep track of my keep track of what's there, and then 1 1 0 0. So this is just a really easy way to break down a hexadecimal number into binary, because each character breaks down into a 4-bit binary number, as Josh was saying earlier. Any other questions about this or any other numbers?
Yeah, so to add on, so like with hex, it has a one-to-one mapping with binary. So I think the original question was converting octal to hexadecimal.
So
So like
octal
something
is
that we
3
should
numbers.
consider.
So what, 7? So octal is like, say, 743. So
I
7
think only you should use
is
2 digits.
let's see, what's that? 4 5 6 7. That's 1 1 1 in binary. Right? 4 is 1 0 0. 3 is 0 1 1. So this in octal is 1 1 1. Somebody check me, make sure I'm right. And can we convert? I'm not sure. Can we convert that by taking this and changing it to can we take this number here and go let's see, 0 1 1. Okay, 0, then 1 1 0. Can we do it this way? Can we just go how many? 1 2 3 4 5 6 7 8 9. 1 2 3 4. So that's 1 1 0 0 0 1 1. Okay, so there's an extra one. Okay, so that's binary, which is the same as this octal number up there. And that is in hexadecimal, that's 1 E 2 3, 1 E 3. Somebody check me, make sure that's right. I usually use a calculator, and if we put in 743 in octal, can I just do that? Okay, no, 743. The calculator converted it for me. It's 743 octal. Is this number the same? 1 1, yeah, 1 2 3 4 ones. 3 zeros and 2 ones. So so the computer, this is how I double check to make sure that I did it right. There's a calculator built into Windows that programmer's calculator that'll automatically convert the common basis. And so the work that I did down here proved correct. So
Yeah.
so when I have an octal number, I converted it to a binary, and I used it in kind of 3-digit spaces to do octal. But then I just down here, I just spaced it out into 4-bit numbers. And that turned out to be back to hex. So we went from 743 to 111100011 to 180 to 1E3, and that's how I converted the numbers.
All right, so going from octal to hex, binary is a better intermediary in between step for conversion because it's easier to convert than to decimal. But I think there might be a way to go from octal directly to hex. Because like if you think about it, octal is 8 and hex is 16. So it's exactly double. So like for the first octal number, that's just gonna go straight into the first hex number. And then for the second octal number, depending on that value, something is gonna get added to the hex number, right? Are you guys understand what I'm saying?
I'm not really understanding what you're saying, but
Like if you like just like just give me a 2-digit hex number and I'll just convert it into binary. Like in the
okay, so you want a
notepad.
hex
Okay.
number?
Can I
Yeah.
butt here? Okay, this thing that Josh is describing is absolutely juicy. Okay, it is a fantastic thing to talk about on the Reddit, because I am 90% sure that even if you had the whole hour to explain this, most students will not be able to appreciate that enough. Okay, but on the Reddit, if you start a thread saying, hey, you know what, going from octal to hexadecimal without using an intermediary, is that what you were trying to do, Josh?
Yeah.
And making use of the relation that, hey, 2 to the 0, 2 to the 1 times octal is actually hexadecimal. Okay, a wonderful insight. Okay, that is absolutely fantastic. And in fact, so some of you should noodle on this before even Josh describes the method on the Reddit. Maybe Josh would just post a question and say, hey, here's something for you to noodle on, extra credit. Yeah. And then maybe after a week or so, Josh can weigh in and say, hey, this is the answer in case you are looking, but you guys can have a chance to crack this, approach this problem sideways along the idea, the hints, the tips that Josh gave, because it's going to take a bit of time to get to the answer that way. Okay, even if you get it instantaneously now, I think for the majority of students, it's going to take a little while to sink in to appreciate that fully. Thank you, Josh. I'm glad I just came in at the right moment to stop the train from going down a very interesting path that is unlikely to end by the end of this class. I think that is my take on this, because there are so many nuances there that you could get into. And if people don't ask those nuanced, interesting questions, that means they actually didn't understand this well enough. The problem that Josh is trying to pose here. Okay, all right. So this was fantastic. All right, thank you, Richard. Okay, now I think that before we go on to two's complement event or 10's complement, I'm happy to do the first one with you guys. Okay, I'll explain 10's complement and then two's complement, how it's related, and then we'll do a problem and you guys take over from there. But before we get to that, what time is it now? 6:51. Okay, let's say for another 10 minutes until about 7 o'clock or 7:10, we'll do one more conversion problem. Okay, maybe I'll walk you through this. Okay, so you'll get 2 different angles. So Richard walk you through one, maybe one more even. Ava will walk you through another, Or other people will walk you through this, right? Maybe Ava will share the screen. Hey, Ava, you took off, but you said you were going to share the screen at some point. I don't know. I don't know if she can hear us.
Can I ask a quick question?
Yeah, sure. Go for it.
So I have tried like the first questing with a hello world, and when I submit it, because we're trying to get used to the system. So I'm enrolled in the Foothill class. So for my student ID, it should be like my Reddit username, right?
No, your student ID should be a student ID. Otherwise, how would I know what Canvas student to assign the points to?
Oh, so I saw in the syllabus it says it's my Reddit or
Oh,
something.
no, definitely not.
So it will be my
Handle should be
campus.
used for the Reddit handle is used for Reddit posts. And then the
Oh.
student ID is used in your quests.
Oh, so it's my campus wide ID, right? The CW ID.
Yeah, yes, student ID.
Oh, okay.
Yeah.
I have like done the
Then,
first two already.
some of you guys are probably using some default Reddit handle. Make sure you're using the right one. Because there's a couple of those people, but not our students, just random questions from out there. They may use these random names, but you
If I-
guys, otherwise I won't be able to give you points.
I could just submit it right now, right? With the right ID, with my correct ID, because I have like a few completed already.
Yeah, you can submit anytime you want, right? And as soon
It
as
doesn't get flagged as because I have tried so many times and failed.
you can say, sure, you can try any number of times, but I think you can talk to the senior students, maybe not even the 2B students, well, towards late 2B. If you get into the bad habit of just submitting lots and lots of times to try and debug what is going on, you'll drop the class in the middle of 2B. You'll get so frustrated, okay? So the way to conquer computer science or any art really, okay, is to do this repeatedly so many times, even in your sleep, so that it just becomes automatic to you in your own mind, so that many things you won't have to run, and you'll have a very good intuition of where to look in order to find the problem, and you'll test it yourself before sending it to the final, right? Then you won't use a questing system as your debugging tool. Lots of students start out doing that into CS2A. But after quest number 6, I think it's very hard to use, because there'll be so many bugs in your program, and they're just relying on the output of the questing system is not enough anymore. You got to develop a way in which you can put cout statements in your program to say, this is what I'm doing, this is what I'm. Later on in your questing, you'll find out how to use a debugger, which is even more powerful. But all of the skills are like super duper valuable skills, okay? It does not matter if AI agents will run the code for you or write the code for you. It is important to actually understand what this does. Because then even if you look at a complex task that is architected and designed by someone else, you will know what is going on under the hood. You won't think that, oh, I got given this magic piece and that's going to do something for me, which is really, if you think about it, that's what we're doing with the emergent AI right now. Because we don't know how it works, but we got this black box and this network that actually seems to have learned emergent behavior that gives us nice fluid English sentences. And we don't know how this grammar came to be because we didn't feed it. And we say, all right, we're just going to use it and hope it doesn't break. That's really what we're doing, really, isn't it? With these large language models, which is hoping it doesn't tell us the wrong answer. And then we're building all these systems around it, saying, well, if it did give an answer and you can check it's wrong, then you weed it out. So all those, right?
So if I just submit my correct answer that I already got right now with my new ID, because I saw in the syllabus you say it's gonna get flagged suspicious if you just do some random ID, right? I don't know, I think you said it, but no?
No, what I mean is if someone what the suspicious ones are what some of the some of the heuristics in the system that I use that flags submissions as suspicious are 1 day before the deadline or 2 days before the deadline. First attempt happens, which is followed by a number of attempts, right? 200, 300, 500 attempts with very little change. And that my system automatically learns very quickly. I say, hey, that student that does not seem to understand what the hell is going on. They're just, throwing wild ass bullets in the dark, hoping one of them will hit the target.
Oh, I see.
Right. So those kinds of things will actually get flagged automatically for me.
I think I tried like Maybe like 3 or 4 times.
No, you can do your heart's content. Yeah, in fact, it doesn't even matter until quest number 6. Until quest number 6, I encourage students to knock themselves out and do as many subs as possible. After that, if you keep doing that, it will work against you rather than in favor.
Oh, I see.
Yeah,
Thank
because
you.
if you keep doing that, you'll just slow you down. Because if you don't do that, you'll develop the skill of saying, well, I'm not going to do that. That's like 1 minute to submit and get the result back, but I'll just run it in my mind and know whether it's going to break or not. Initially, it'll be hard, but after a while, you'll find that you can get it in less than a second, right? With very high accuracy. So you won't be testing so many times. When you do test, it'll be a significant change. And in the beginning, when you do CS2A, students will test little things. Even in your own debugger and stuff like that, I found, the newbie programmers, they will test small changes. And even the more experienced programmers will test small changes, but the smallness of their changes will be bigger, meaning that they'll change. They'll be working on something that big, and they'll test here rather than something this big and there, right? But it's you have to do incremental testing. But as you code more and more, you will get into the subconscious habit, in my opinion, subconscious habit of just simulating things in your head, okay, so that you don't have to run things. And this is natural human behavior shaped, I believe, by millions of years of evolution, okay? If you keep doing something repeatedly, the system will figure out a way in which the same thing can be done for less energy. And that is our root of laziness, essentially, right? So if you keep on doing something and say, well, you know what, how can I do this with less effort, moving less atoms, right, burning less calories, whatever it is, say, well, you know what, I'm going to try and just run it in my head. Okay, and so the wise people eventually, when they have to act like Confucius, will say, well, you know what, let me first think about it and tell you whether it's worth it or not, right? Rather than actually rush into battle and find out, oh, all right, okay, we lost, okay? And so you can think about it, simulate it in your head, and look at the final outcome. And the better your own computing machinery is, and the more experience and practice you have in simulating environments and complex environments in your head, the more accurately you can predict and say, well, is it going to be worth it or not? And so computer science, and especially programming, I think is a fantastic start because it introduces you to this iterative way of thinking about life in general. Saying, well, you know what, instead of releasing it into the wild and having my customers play with this and possibly get burned, I'm just going to simulate it now and see if it works, okay? And simulating things is hard at first. But I think over time, you'll find that I'm doing this so many times. Let me figure out each person will find different ways, I guess. But eventually, you'll just be able to do it automatically. Many of these things, as much as, initially you simulate a little and so more and more, so on, right? One time when I was an undergrad student or early grad student, before I switched topics, we did an experiment with chess to see how grandmasters and novices thought about the game as they were playing. We asked them to think aloud and recorded what they were thinking. Interesting things. Anyway, so that's what it is. So if you want, we'll do one more base conversion. Yeah, and I will walk you through this. Any base to any base. It doesn't have to be the same one, like a hexadecimal. Or if you want the same thing, we can do the same thing too, right? We can do the same thing. Not exactly, maybe not the same number that Richard worked on. A different number, but the same idea that Richard was trying to explain. I'll explain it with my perspective. And maybe when Ava is ready, she can explain it with her perspective. And then that will hopefully give all of you 3 different perspectives, right? No, 4 actually, because there was one where Josh was also explaining something. And I think that is enough to get a good view of how these bases work. How about that? Is that okay? Hey, Brandon, you got your hand up.
Yeah, I kind of just wanted to ask you a quick question if I can kind of like get a thought process check, I guess, because I was thinking about Richard's example of like text to binary and octal to binary, and I was thinking back on Mark's original question of like converting hexadecimal to binary and then how that kind of translates to converting like an octal to binary. And I guess correct me if I'm wrong on this, but I'm thinking that I guess because each binary digit is a bit, When you have 4 of them stacked together, then your max output, I guess, is 15 because
Yeah.
0 is the first number. But essentially, that is 1 digit in hex. And then for octal, the reason why there's only 3 bits in a row is because that's the max for octal in terms of the, I guess, max capacity that it has, which is 7, 0 to 7, I guess. So when you have like an octal number of 7 and you're bringing it to binary, it directly translates over with those 3 digits, I guess, representing that octal number.
Yeah.
Binary.
Yeah. The thing is, there's more to it than this, and it is actually worthwhile doing a very little bit of research. Just some Google. There's interesting history with this too, and I'll go over very, very quickly. And you can do some research and share on the Reddit. Now, octal is basically 3 bits. With 3 bits is octal notation, and historically, if you look at the Unix operating system, they actually had uses for octets. It comes from data communication days. The octets, right? No, octet is a byte, right? But they had uses for 3 bits together. It goes to the heart of the Unix operating system and so on and so forth. Then 3 bits together. Okay, so that's octal value. And so for historical reasons, we can still continue to use octal. It's actually buried deep inside the Unix permission system. Okay, there is octal values in there. Also, you can research all of these things. There are interesting trivia. Share these things on the Reddit. In addition to asking here, like Brandon did, you can ask a question in class, like Brandon did. Some concept check, and say, hey, you know what? After we talked about this with the prof during class, I went ahead and did some research on my own, and here's some interesting info I found on the history of octal. Right, and its relation to old operating systems. Well, actually, Unix is not an old operating system, right? Chances are this very system is running on some version of Linux, which is a public version of Unix. Yes, so it still uses Linux. Yeah, they use octal in the permission. In many ways, this is 3 bits together. How does it actually add up? There's something. It was related to one other bit called set2it. I actually forgot the details, but I think it is octal is 3, right? Okay, so octal. So we can do one more conversion. Okay, and then unless Ava wants to go first, right? Ava, if you want to go first, you can take the screen and then basically convert one number, just in the same kind of conversion that Richard did, but your way. Now it could be the same way, but if you do it one more time, then students will actually gel better into this. Obviously, you got to learn about two's complement and all these other things too. We'll go into that later today if we have time, but you still have to learn about all this before tomorrow, because that's when the midterm is. So this is Eva's screen. Eva, all right, great. Okay, all right. So yeah, is this Richard's question? Up there is what you have up there was Richard's one, was it?
Yeah, I just typed it out on my own too.
Yeah, okay, all right. So you can do something very similar. So type out some octal number, hexadecimal number, and say I want to convert that to. What did he do? Oh, he went from. Hey, Richard, what did you do there? A6 to. Oh, I see. You just did the map and said A is this and so on and so forth, and put them together. Oh, and then you did one more 743 to that. Okay, octal you divide into 3, and all right, okay. And how did you go from 743 to that number, the binary number?
All I did was take the binary number that is represented with 3 bits each.
Oh, I see. Okay.
And I combined them together down here. And
Okay.
separated them out into 4 bits, and then that's the hex.
Very nice, very nice. Okay. These things shouldn't just be lost in the videos, because how many people are gonna, AI will obviously scrub through it and find all these details, like the needle in a haystack. But you should also, in addition to doing this, you should also talk about something this in a Reddit post and link to a YouTube video timestamp, right? &T equals this thing in the video. Well, if we share it. Because these are interesting things. Now, what we can do is, you can also convert without going to binary directly from. Oh, that's what that led into the discussion, I guess. All right, so go directly from hexadecimal to octal. And Josh, Okay, so we don't want to talk about that. Yeah, but that is an interesting question. So put it there, right? Write down the question, right? Develop the idea that Josh talked about. Yeah, hey, Ava, write this down, and then we'll go into your problem. Okay, write this down.
Okay.
Develop the idea that Josh introduced. And Josh, you should correct me if I'm wrong here, okay? Which is to convert a number from hexadecimal to octal directly without going to binary.
I have it up here.
Oh, yeah. Okay, so may put a comment there saying discuss in the forums. Okay, put a comment on your question on the previous thing, right where you had the question there. You and then when students read that, they'll know that you get points for discussing this. Okay, so for now, pick another octal number, and we want to convert that from octal to binary. Yeah, octal to binary. Let me see. How many other ways in which you can do it? The easiest way, of course, is to
So,
yeah.
what
No,
did
you
you
don't
want
need
me to
this
do
anymore.
now?
You know, you have that already. You told me you have a question. Yeah. All right, now your question. So you want to convert a number, OX, and then come up with a hexadecimal number. All of you guys, anyone can come up with a number, and we want to convert that into binary. And we can do exactly, and someone other than Richard now will have to walk Ava through the steps, and I will be there for backup. Richard is here, Josh is here, Caitlin is here. We're all here. Someone should do it just to make sure it's good measure. Okay, everybody will be on the same footing, on the same page, and understand what the hell is going on here. Yeah. Okay. So, Ava, yeah, thank you. OX, and yeah, someone call out a number. Okay, some 4-digit number or 5-digit number. No, do a 4-digit number. And easier. 4-digit number. And by the way, how many bytes is a 4-digit hexadecimal? Can someone tell me how many bytes that is? Write down a 4-digit number. Can someone call me call it a 4-digit hexadecimal number?
A4B5.
A4B5. Okay, right. A4B5. Yeah. Okay. All right. A4B5. So we want to convert that from convert to binary. So we want to convert that to binary. So can someone other than Richard walk Ava through the steps of converting that to binary? Now, is there another way to do it rather than just the way that Richard did? That's one way. Okay, one way is to say that each someone was trying to explain that too, right? After Richard did this, Brandon, yeah, was trying to explain this, yeah, where you have a map and say, hey, each digit that you just substitute by that and chop up differently, and you get the octal version. All right. So you can do it either that way or a different way. So I'm not talking, okay? I'm just looking at it and thinking of different ways to do it. I'm just waiting for someone to step in and say, hey, Ava, well, this is what you do next, okay? Ideally not Richard, because he's done it once before. And not the tutors or Caitlin either. So one of you. While I'm thinking of something interesting to say about this, someone should keep the airwaves occupied and talk, okay? Basically walk Ava through the problem, because you have to understand that the person who volunteers to share the screen is actually just brave enough to be the front-facing typist, essentially, which means that we all have to have that person's back and say, well, what, take the screen and type, but we have you back. We'll make sure that you're not going to get stuck. So if we'll tell you what to type and so on. Is that okay? Otherwise, think about it. If you didn't have that guarantee, would you be willing to go on stage like that? No. Yes. Okay. So we got to understand first that everybody has everybody's back here. Otherwise, there's no point. So when Ava's typing, you're all, everybody's active mentally and thinking, what are we going to do? So I'm basically going to be silent now because I'm trying to see if there's anything interesting I can, boil out of this for a few minutes. Okay, give me a couple of minutes. During that time, you guys should basically chime in at this point and say, hey, Ava, this is what you do. Okay.
Yeah, I was thinking my first step would probably be to split up all the numbers and then kind of just list them down in their own row. From there, I would probably translate A into 10. Or yeah, just straight to binary
Oh,
as well definitely
uh,
works.
yeah.
I'm sorry.
Um,
You said to 10?
yeah.
Okay.
And then 4, yeah, would just equal 4 as well. That's fine. I guess just kind of like visually representing kind of more the letter notation that hexadecimal has. Yeah. And then from there we can go ahead and do what you're mentioning.
So this one the first step was to convert the hex to a decimal. That
Yeah,
was the
pretty
first step.
much.
Okay.
No, I don't
Right.
know if that's the right thing to say,
I
because
think
when
it's still
you say,
hex, right?
you're just converting the hex digits to decimal, I think, not
The
the
digits to decimal.
yeah, because if you say converting the hex to decimal, it means you're converting the whole number, which is given to you in hex, into decimal. That's not what you're doing. Yeah.
Yeah.
So I think yeah, I understand what you're trying to say, but I think you got to find a better way of doing that. The digits for now. You gotta say take the digits and convert to.
And then from here, I would say, we can go ahead and convert those 4 digits, 10, 4, 11, and 5 into their respective binary, I guess, conversions, but also making sure that they're represented using 4 numbers so that they can kind of get their full nibble representation.
Okay.
So,
So 10
let's see.
is 10, 10. Is that correct?
I believe so.
Yeah. And 4 would be like 0, 0, 1, 0. You got it.
0, 0. Oh,
0,
0,
0, 1,
1,
0,
0.
0. Okay.
And then 11 equals
Is 1, 0, 1, 1.
0, 1, 1.
5, 0.
Equals 0, 0, 1.
Yep. Yeah. And then so after this, you would just get the binary by taking those numbers and kind of putting them in order. Starting with the 1, 0, 1, 0.
Of starting from 1, 0, 1, 0.
Yeah.
Okay.
And I think to answer the professor's question earlier, this is 2 bytes. If I'm thinking of that correctly. And then that would pretty much complete the hexadecimal to binary.
Are you done? Are you guys done?
Yes.
I believe so.
Oh, fantastic. All right. Great. That is absolutely fantastic. Okay. I couldn't find, I couldn't think of a more, I couldn't think of something interesting or even a different way to do this than the one that Richard suggested. That would be easy enough and as easy and straightforward as this. But there is something interesting here that you can talk about in the forums, because even though it is not so difficult, it is not totally obvious why this works, okay? Because we have these big patterns for individual things, and I think Brandon went into a little bit of an explanation as to why this should work, but digging into that a little bit more to find out, hey, this is exactly what it is, and this is how these relate to the quantities and so on. Just talking about it, maybe it's a paragraph or something, just leave a little footprint of your insight on the Reddit saying, hey, I thought about this. I was here, Brandon was here, plant a flag as you're going and say, hey, that's really interesting. Why does this thing work? We're just looking at these 4-bit things, or 4 bits, like 0 to 15, and how does it actually go into the binary? And this is how the transition happens. There will be lots of situations like this. Not all of them will be as easy as this, obviously, because here it's like in 2 or 3 steps, right? You're going from here by, and then powers of 2 and so on. You can actually see everything, visualize. But as you go into the more difficult problems, you'll be able to convince yourself that you can do all these jumps and end up here. But once you end up here, it's not so obvious anymore, right? It looks like magic going from here to there, but you're just following a sequence of steps. But by doing all these little dances and getting comfortable with that, these big ones will become automatic for you too, right? Because you'll be capable of making these larger leaps with more confidence. Otherwise, people don't go down those paths, I think, because students tend to be scared.
So I have another question, actually,
Go for it.
regarding this. In the reading that we had, they converted using division and like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Can you show an example of converting, like these are like standard bases like octals and hexadecimal and decimal, but like for like the homework assignment of 27, that's too big for now, but a real simple example of using that division method to convert from one base to another.
Yeah, sure. Why don't you, how about that? Thank you so much. Who asked that question? Was it Richard?
Yeah, sir.
Yeah, fantastic. Thank you. I'm absolutely happy to show you that. How about we try and convert a number? We do the same thing that Ava tried to do. We'll try to convert into octal using the division method. How about that? Is that a good idea? Maybe we'll take a decimal number. I think that's the easiest to do, right? We'll take a decimal number and try to convert it to octal using that division technique that you did last class to convert from decimal to binary. Didn't you do this last class, right? Someone did this last class. Who was it? Jin maybe. Is Jin here today? Jin, you are here, right? Did you share the screen last class? Yes? Because we took a number and then divided by 2, took the remainder. And
yes,
then,
yes.
all right. Now, I think Richard says, let's try and do this one more time, but going to a different base. Isn't that what you're asking, Richard?
Yeah, with something that's like a non-standard kind of base.
Yes,
Something-
8. Oh yeah. All right. How about we can do base 9. Maybe pick some random base. 27 is good. I mean, it's because why don't we do 27? Because with 27, it'll also give you a good idea of how to do this. Your name conversion. Hey, Richard, you already did yours. I think you did. You went to hexadecimal from your name? Yeah. Or you could try Dick. Maybe you'll get something that's pronounceable. With Richard, I saw that you didn't get a pronounceable hexadecimal version.
Right.
You can try variations and so on. At one time there was a student with a hyphenated name in class, right? And how am I going to convert my hyphenated name? And I say it's really simple. A hyphenated name, this minus that. That is you convert this, convert that, and then subtract this from that, and base 27, you get your or whatever it is, right? So that is what the hyphenated. So you should thank yourself. Thank your stars that you don't have hyphenated names. But yeah, we can do base 27 conversion using this division technique. We did it in the modules, I'm pretty sure. But we can do it. I'll walk you through this. It is exactly the same in any base, but we're just doing base 27, not because it's hard or the hardest of all of these things, but because once you know how to do it, you can just, is that okay, Richard? Can we do base 27?
Yeah, anything you like. I just want more practice seeing it so that it sticks better.
Let's do this. Okay. All right. How about someone other than Ava? And I'm going to walk you through this. Okay. So you just need to be a typist. Anyone. You just need to be a typist. And of course, if you know what you're doing, you can also go ahead and type. Even if you don't know what you're doing, if you're bold enough, just go ahead and type. All we have to do is erase and sometimes make corrections. So you're welcome to type ahead. But the thing is, if you don't have to worry, if you don't know what to do, you just wait there for me or someone to walk you through this. Okay. It's going to be fun. What we'll do is whoever takes the screen, we'll take their name we'll do their last name, okay? Not their first name, last name, and convert it from base 27 to decimal, okay? And then you also know how to convert from base decimal to 27 to hexadecimal, all these things. We can play around with these things, okay? Who wants to do it? You have to share the screen just like Richard.
I can share my screen.
All right, Francis, go for it. Okay, share your screen and then go to Notepad. All right, okay. Well, so your last name is YU?
Yes.
All right, okay. How about we convert the name Frank? Okay, but in your actual post, you could take Francis.
Okay.
Yeah, so we'll have to do something. You got the name Frank, base 27 to decimal and hexadecimal too, right? You can say and hexadecimal. So we'll go to decimal first. We'll try to go to decimal first. Okay. All right. So Frank has 5 digits, isn't it? So if you look at the our numbers as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's for base 10. But for our numbers, we have a space that is 0. And then A, B, C, D, E, F, G, H. That is, all of that is for 1, 2, 3, 4, 5, 6, 7, 8, up to Z. And Z is 25, 26, right? 1 to 26. All right. Okay. So Frank is essentially going to be K times 27 to the 0. K times 27 to the 0. Yeah. Plus N times 27 to the 1. Right, so I'm not going to talk about. I'm not going to do those, and neither is Frank. Right? Maybe Frank can, but someone else should basically call out what the rest of it should be. What is the rest of this? Imagine that Frank was a decimal number. You're going from this side to this side, right? Increasing powers of 10. No, but Frank is a base 27 number. You're going from K to F, this direction, starting from 27 to the 0, all the way to 27 to the 4. Yeah. Go ahead. Go ahead and do it. Take a guess. Doesn't have to be right. The most important thing is to take a guess. It does not have to be right at all. No, don't talk. Or don't use the chat. Okay, I'm just maybe chat should just be disabled. Puneet, you basically call out. You should talk. If you're not talking, you also don't get a point.
I'm guessing R would be 27 to the 3rd.
Can I do that?
And I'm guessing F would be 27 to the 4th, or to the, yeah, plus F.
Yeah. Okay. All right. Now, so so you can K. What is K? A, B, C, D, E, F, G, H, I, J, K. K is 11, isn't it? So you can rewrite the whole thing. K is 11. Is it 11? K is 11, isn't it? Someone should confirm these things. A, B, C, D.
It is.
Isn't it 10 because 0 is A?
No, 0 is space.
Oh,
We're
yeah.
using
Oh,
a-
sorry, my bad.
Yeah. You got to check the spec. I think 0 is space. But anyway, you can. If there's a mistake, you should fix it. Okay, before. Okay. Yeah, and that equals 11 times 27 plus KLMN. So 11, 12, 13, 14, 15. N should be 15. 15 times 27. And you can basically get rid of the power 0 and power 1 and all. So instead of it's basically 11 times 1. 11 times 1. No, 11 times 1, because 27
Is 11 or oh, sorry to interrupt, but is N 15 or 14? I think it's 14, but I just want somebody to also double check. Yeah.
HIJKL.
Yeah, N is 14.
Yeah, 14. But K, what was K? K was 11. Yeah, whatever. 14 is correct.
K is 11.
Yeah. K is 11. 14 times 27. 14 times 27. That's 27 to the 1. Yeah, and then A is 1. 1 times 27 squared. What is 27 squared? 30 squared is 900. So it should be something above 800. And between 800 and 900, 27 and in a 9. What is, can someone find out what
729.
729. Yeah,
729?
yeah.
729. And also find out cubed and squared to the power 4.
Yeah, I've got all of them right here written down.
Okay, can you call them out, Richard?
Sure. Okay, to the third is 157464.
19. Oh, I see.
I'm
15.
sorry, 157464 for the cubed.
7464. 7464. And what is R? R is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. That's 16. Q, R. 18, isn't it?
Okay, the next number for 27 to the fourth is 1594323.
Okay. And that is A, B, C, D, E, F, six times. Right? Someone should use their calculator and find out what this value is and tell us what the, and then you can say equals and then type that number in. And then what we're going to do is take that number and divide it by 16 and convert it to base 16. Okay?
Is 27 to the third power right? Because I think it's supposed to be 19,683.
Is it right, Richard? That's what you said? It seems different from what Richard called out. No, how could it end in a 3? It seems like a prime number really to me. But it's supposed to be 27 to the 3. 7 times 7.
157. 15.
That's 63.
There it is. That's what I have.
27 to the 3. But it has to end in a 3. Why is it ending in a 4? And it's, 27 to 3 should be an odd number, shouldn't it? Why is it an even number?
Yeah, I got
It's
19,683 for
19
27 to
as well.
the 3.
Hey, Richard, why is it an even number? It should be an odd number. Thank you. Yeah. 19683. Can you check the other one also, 27 to the 4?
I got 531,441.
Oh, okay. Oh, yeah, that should also be odd, obviously. Yeah. Yeah.
That's why I redid it all in Excel.
Yeah.
That's my math.
All right. Also, we can do these quick checks because we know that 27 to the cube or 27 to the 4 is, 7 to the 4. Whatever 7 to the 4 ends in is what this also has to end in. And we know it's got to be an odd number. And 7 times 7 is 49. So 9 times 9 is 81. That ends in a 1. So whatever you get here has to end in a 1. If it doesn't end in a 1, there's something wacky there. Okay, especially if it's ending in a 4 and all, we know it's an even number.
Oh, you know what? I'm so sorry. Those numbers are obviously the wrong numbers. It's the digit multiplied by my name. By the
I see. Okay.
Okay, I see.
I see. You got you.
I got them written down in my notebook here, but I got the wrong column. I'm sorry.
Yes. Richard saying he is that what the numbers you called it was the next step. After doing the multiplication, he got the column of numbers, and that's what he was calling out. And the next number is next row is 729, and whatever 18 times 19,683 is.
That would be 354,294.
And the last one, you add them all up, and that's your total. So that's our decimal value. And from decimal, let's go to let's go to hexadecimal using the technique that Richard asked, which is keep dividing and dividing by 16 and taking the remainder. Okay, very straightforward. I'll walk you through this, but you should also be able to walk each other through this. But we won't do any more of that, okay? After that, we'll do 2's complement. All right, can someone add it all up and say what the value is?
3,544,058.
Is that it? Yeah. Okay. All right. Okay. So that is a decimal equivalent. We want to convert that. So on the next line, you can say convert that to hexadecimal. Convert that to hexadecimal by repeated division, using repeated division by 16. Okay. So we're going to do exactly the same thing that we did binary before, except we're going to divide by 16 and take the remainder by dividing by 16. Okay. All right. So go on to the next line and say copy and paste that big number. Yeah, and say slash 16 equals. Can someone divide and tell us what the quotient and the remainder is? Basically, if you want to, I don't know, some calculators tell you what the quotient and the remainder is when you do the division. If not, you got the quotient is, when you divide something, you know, it may say it's 19.45. The 19 is the quotient. And the 0.45 is 0.45 off this thing, right? It's kind of crazy. There are some calculators I know, okay, that tell you what the quotient and the remainder are. No, not remainder 10, okay? We want to remainder 16. Oh, I see, remainder 10. Oh, I see. Oh, is that what it is? Thank you. Oh, Francis, all right, you're typing. That's what, is that what it is? So it goes, that is a quotient.
That's, yeah, people are typing in the chat. I'm just copying.
Thank you so much. Hey, by the way, people typing in chat, you're totally not getting any participation points for these things, okay? If you're not talking and speaking up, because chat is going to get deleted. I don't even look at these things. My bot is going to crawl the chat to pick up the people who say hello when you're present. Okay, by chat and saying I was very participative in class, but you can go and mind the chat. No, absolutely not. You weren't speaking up, so you know you don't get any participation points for class. Okay, and so I have to enforce these things. Otherwise, people just kind of slack off or talk in chat because it's safer. And the safer meaning you can also not talk, and then it won't be noticed so much. So don't use a chat other than for attendance purposes, because it'll make it harder for the crawler too if you have other data. So please don't use chat. And I also said that when Puneet was typing something in the chat, okay? So I'll see if Zoom is able to disable the chat for these things. Please talk. And I'm always the only one who's always talking, okay? It's only the second class, obviously. I'm not complaining.
Professor.
I shouldn't be the only one
Hi,
talking.
Professor. I'm sorry to type in the chat, but I'm in the library right now, so can I will talk next time. But
all right, that's fine. Okay, but it's not just you.
Yeah.
But because someone
okay.
said, Francis said people are, okay, not just you. So many people.
I understand.
So
Thank
not
you.
everybody's in the library. Yeah, even in the library, there are conference rooms you can just go into, and then you can talk.
Yeah, I will go next class.
Yeah, awesome. Okay, all right. So on the next line, yeah, and remainder 10, isn't it? Remainder 10, and 10. You can say AKA space, also called as A, right? A, uppercase A. All right, next line. 221,503 divided by 16 equals. Do the same thing.
The quotient would be 13,843 with a remainder of 15.
Thank you, Matthias. Was that Matthias?
Yes.
Great. Okay, and AKA, what is 15?
It would be E, I think.
No, F.
Oh, F? Oh, wait. Yeah, that makes sense.
Oh, I see. I was starting to worry. Why the hell is it not going back to Frank? But obviously, no, we're going to hexadecimal here. Okay, all right, yeah. All right. Now, yeah, 13843 divided by 16. What is it?
$865 with a remainder of 3.
65 with a remainder. Wait, thank you. And 3 aka 3. Yeah, all right. Now what is it? A65 divided by 16 equals.
Uh, 54 with a remainder of 1, which is 1.
Three with a remainder of 6.
That's absolutely really cool. Okay. In fact, if you think about it, and ponder this and chat in the forums also, you can keep on doing this. It doesn't change the value at all, because you can say, well, 3 divided by 16 is 0, remainder 3, right? And then you say 0 divided by 16 is 0, remainder 0. 0 divided by 16 is 0, remainder. You can do that any number of times. Why does it not make a difference? Because each one of those is basically going to add a 0 to the beginning of the number. And as you know that you can add as many zeros as you want to the beginning of a number, it doesn't change the value. Yes? Because 15 is the same as 015, it's the same as 0015. But if you add zeros to the other side, it makes a huge difference. Same thing here. All right. So that's why we can keep on and it doesn't make any difference. So anyway, since we got to a 0, we know that's where it's going to stop. And now you can read off the remainders in reverse in hexadecimal, and that is your hexadecimal conversion. Okay, so what is it? 3613 FA. So unfortunately, Frank, this is not a pronounceable name. EBIEFA, EBIFA. I don't know, it's in elite speak, that could probably EBIFA, right?
Yeah.
EBIFA. All right. Well, I don't know. It's okay. It's pronounceable marginally. It's not like Abe. Someone should come up with something like Abe. That is the best ever hexadecimal name we've got so far. Okay, now what do we do? Right. So now let's convert this to binary with this technique that Richard used last class. Oh, I don't know. Maybe Richard tried to go from this to this direction. We'll try and do this. Okay. So now 3 is going to be 4. Yeah. No, you can actually do this even better. What we'll do. Just type for 3. What is 3 in hexadecimal? 0011. So convert each digit into a 4-digit hexadecimal number. That's all. Yeah. I think that's good. Yeah. No, 3 and then lots of spaces, and then say 3 and then 4 spaces. Yeah, you just need 4 spaces, I think. Or 5 spaces, 5 spaces. And then 6, 5 spaces, 1, 5 spaces, 3, 5 spaces, and so on. Oh, you want to do it on successive lines? That's it.
Oh, I see.
Yeah, no, that's fine. That's fine. Do it the best way, because if you think that came intuitively to you, it would have come intuitively to a lot of students. So better to do it the way that just came naturally to you. Zero, zero, 1, 0.
Zero, 1, 1, 0.
Hey, 3 is not 0, 0, 1, 0. Sorry.
3 is 0011.
Yeah.
0, 0, 0, 1.
0, 1.
Three would be 0, 0, 1, 1 again.
1, 1, 1, 1.
All ones. And 1010.
Now write them all out as one big binary number. Yeah. So and then you can put 0b in front of it. That means it's a binary. Instead of 0x is a hexadecimal, right? 0b is binary, right? So it looks kind of ugly, right? Get rid of the 0b. I think you should say binary version, binary equals. Yeah, yeah, in binary. Yeah, yeah. All right. Now, let's do what Richard tried with the other thing, right? To convert to octal, we want to basically put a comma after every 3 characters here. Put a comma after in the binary representation. Put a comma after every 3.
You want to start from the right-hand side.
Yeah, yeah, and because you can pad with zeros on this side. Is it right? 0, 0, 1.
Sorry.
No, there's 3 from the right side. After the 3 ones on the right, put a comma. Oh, I see. You missed something. Yeah, well, actually, divisible. See, we lucked out here. We didn't have to pad with extra zeros here. 4, 4. Oh, because it was six digits, and you can. Okay, now you want to convert each of those into an octal number. Okay, so the first one is what? The first digit is 1. The second digit is on the next line. Yeah, that is 1, and the second digit is 5, because 101 is 4 plus 1, 5, isn't it? All right, so this one is 4, 1, right, and then 1, and then 7, 7, and then this is 2. Now, here's the cool thing. Now, if you convert this octal number back to decimal, you should get the exact same value that whatever that thing is, right? Before you convert it to, right? If you convert this into decimal, how do you convert this to decimal? All you have to do is, hey, this is a number in octal. So I want to know there's 2 8 to the zeros. Okay, there's 7 8 to the ones. There's 7 8 squares, and so on, right? So on the next line, type here, converting back to decimal, converting back to decimal. It's a huge practice in this one problem, this practice. Just essentially, take a musical scale going all the way up and down, jumping here, back and forth, everywhere, right? So just to get totally familiar with the layout of the land. Like that, we take a number, we try to convert here, come back this way, reverse, right? Try to twists and turns all over the place, and just get completely familiar with all the different conversions. You don't need to work through multiple problems. Just take one, because it's the scope to, go everywhere. So this problem, we're taking that, and we and also you're generating checkpoints, because when you convert this back to decimal, you should end up with the exact same number here that you started with. If you don't end up with the same number, there's something wacky, something has gone wrong. So you need to go and figure that out. Yes. Now, if in case it doesn't match, you should try to do it, obviously, and say, well, why is it not matching? But afterwards, you should say, well, it's not matching. I'm going to ask in the Reddit, and you should take a photo of, your notebook and say, hey, I tried to do this, but it's not coming back to the decimal. Can someone point out what the error is? And you'll be surprised, because many times, even if you have a lot of experience, sometimes it just doesn't match up. Right. And in fact, I know I've from the distant past, I know some accountant friends, professional accountants who've done a lot of, but they say sometimes, after doing these things, it has to match. These numbers don't match. They're off by a few cents, but they don't, and it just magically disappear. And like that. Yeah, I don't know where that came into the picture at all. But basically, you should say every time you just keep doing this, you should convert back and check back, convert and check back. Oh, now after I do this step, this should be the same that I started with there. Okay, so you'd be able to do a lot of conversion. I think this one thing is good enough to give you a good overview and of a lot of different ways of converting just within all bases. Because here we started with that with base 27, and then hexadecimal, octal back to decimal. Okay, so you're going to say this number has 2 8 to the zeros. Yeah, 2 8 to the zeros, 2 times 8 to the 0, 2 times 8 to the 0, plus 7 times 8, plus 7 times 64, plus 7 times 32, and 142. What is it? What is 64 times 8? 48 plus 3, 512. Is in yeah, is it 512?
Yeah, that's what I got.
Great, okay. What's the next one? Plus 1 times 8 to the
4096.
4096. Thank you. Great. Yeah, go ahead. And the next one, plus 4 times. Uh, 4096 times 8.
32,768.
32,768. Now, some of you watching may think that, hey, some people are just reading out these numbers and they seem to know what's going on, but I have no clue what's going on. It's okay. All right. If you don't understand how these other people are able to call out these numbers, all you need to do is just take a few hours, just read through the document, and you'll just be comfortable yourself too. It just takes a little bit of investment of your time. Just do it. And you'll find that, right? I'm pretty sure there's 1 or 2 students in class who still don't understand. Hey, how is it that, Richard and all these people are just saying what the number is and they're typing, right? Yeah, it's a feeling that, everybody will see different programs in which they feel that way. But if you do feel that way, you just have to ask, hey, I don't understand this. What am I missing? Okay. And we're all here to help you figure out what's going on. All right, go ahead. 5 times, what is the next power of 8?
262,144.
Great. And then we have one more. 1 times. And then this times 8 also, right? Oh, no, oh, yeah. Is that what it is? Okay.
Just let me know if I'm wrong.
Yeah, that looks right. Can someone calculate the total and tell me what it is? And in fact, that total should be exactly what we calculated before. It should be 354,4058. But let's see. What is the total? Are people calculating the total? Or is everybody waiting for someone else to calculate the total? And then we're all waiting.
I'm calculating it right now, but give me a sec.
The total is 3544058.
Great. Hey, so it is exactly what we started with. That is cool. Well, who was it? Ava? Was it you?
Tug Soyum.
Oh, Jackson. All right. Thank you. All right. Okay. And I'm so glad it's the exact same number that we started with. Yes, that's the number we started after when we got from a base 27 conversion, isn't it? So we got back there. Now what we can do is try to convert this number to base. Well, if you want, you can convert this number to base 8 by dividing by 8 and taking the. We did that already once.
I think.
What's left? What else do we need to do here?
No, we did. Well, we did decimal to hexadecimal.
Convert it back to base 27 so that it says Frank again.
Oh, yeah. All right, so we want to convert back to base 27. Convert back to base 20. Thank you. Who said that? Richard, was that you? Was that you?
Yes, sir.
Yeah, thank you. Yeah, so that we can do that. Okay, we didn't do that. So all right, so that's very simple and straightforward to do. Okay, does someone want to call out how to do this? Okay, we just have to divide by 27, take the remainder. Divide by 27, take the remainder. Okay, and you only have to do it 5 times, and you'll get the answer. Okay, so yeah, all right. So can someone divide by 27 and say what the quotient and remainder are? And tell you what the remainder is going to be, right? I think the remainder is going to be 11, if I'm not mistaken. Right? The remainder is going to be 11, but I don't know what the quotient is going to be. Okay, can someone divide and tell us what it's going to be?
The quotient's 131,261.
And what's the remainder? Well, you didn't tell us what
it was 11.
11. All right, thank you. That's great. Okay. All right.
$4,861 with remainder
Sorry, what?
14.
Sorry, I didn't catch that. 4,000.
4,861 with remainder 14.
Great, thank you, Wendy. All right, it's predictable, totally predictable. All right, and I think the next remainder, you should have a remainder of 1.
It's
Okay?
180 remainder 1.
Hey, that is so cool. All right, the next remainder should be 18. Yeah, I think the next remainder should be 18.
6.
6 remainder 8. Yeah.
All right, and I think the next remainder should be someone else say what it is. Oh, you got it already. 0 remainder 6. Okay, now you know, yeah, translate those numbers into their corresponding letters with AKA, right? Great. Okay. And thanks to Richard, we actually did get this interesting problem, you know, did a completed full circle. So we started with a number, we went through a bunch of different conversions, you know, and then came back here. I think it was a worthwhile exercise. And even though we didn't get to 2's complement, I think this was actually worthwhile, you know, hands up if you think this was worthwhile, you know, going into this thing, along with all of the, yeah, thank you, Richard. Okay, so with all the digressions and the ideas that everybody's contributed, and Richard and all these other people, I think it was totally worthwhile that we didn't cut it short and say, well, you know, you guys figure it out yourself, and we'll talk about 2's complement. And in the end, we would have covered 2 topics, not deeply enough in either. I'm happier that we did this. What I would suggest, though, is that you either arrange a time with Caitlin and Josh. Where's Josh? Josh, are you here? Hey, Josh, are you here?
I'm here.
Oh, there you are. Okay. Yeah. Okay. So arrange a time with Caitlin or Josh to Zoom, or I think Josh has this tutorial session on Mondays or something like that. Monday's too late, actually, for the quiz.
Yeah, I want to remind everybody, I made a post on Reddit. It's titled Welcome to CS2A. Right. Suggest your best available times, and I'll let everybody know on Sunday what time it's actually going to be in.
Yeah, even Sunday is actually a bit late for, you can let that, you know, you can decide that separately, but see if you can make a time with Josh or a STEM tutor or with Caitlin to get together on Zoom or in a STEM center room or in a library conference room, whatever it is, a bunch of people, some electronic, virtually, work through understanding 2's complement, okay? From the perspective of 10's complement. I don't know what 2's complement is, but let me look at what 10's complement does. Yeah, and do you guys remember, Josh and Caitlin, do you remember 10's complement and what 10's complement does and how to go from 10's complement? Yeah, right. They can talk about that as an example and say, well, this 10's complement will do the same thing with 2's complement, you know, with bits. So you need to work through just two or three problems, and then you'll understand what it is, the principle behind this thing, this very powerful data representation technique. It is not just useful to know 2's complement, in my opinion, of you know, oh, this is how numbers are represented, I need to know how this. No, that is not the reason. Okay, I recommend students understand 2's complement, regardless of whether, because you don't need to know 2's complement in order to write sophisticated programs. You know, that is the truth. You can actually do a lot of things without understanding this. But by understanding 2's complement, you get a great deal of insight into how computer scientists actually, approach some of these problems. Okay, we take limitations and turn them into advantages, right? We take the limitation that, you know, there's only 2 states possible per bit. You can't have a negative sign or a dash or things like that, but we still want a negative number. And we want to, you know, not waste bit patterns. and so on and so forth. All of these come together to give you an intelligent solution. Okay, intelligent solution, which is not immediately obvious, because if you think about it, 2's complement is not immediately obvious to anyone as a negative number. So if you give someone a bit pattern and say, this, it's 2's complement negative number, yeah, okay, if you have a little bit of practice, you can say, well, it's a negative number, right? But for most people, even after you understand how it works and all these things, just getting an intuition for why is it that 2's complement is important? Why do we use this? Okay, that takes a little bit of time, just marinating in it and thinking about it when you're walking, right? Hey, why, and doing that. Because when you think about these things, you'll actually understand some of the ways in which generally all computer science problems are approached. Because there's a little bit of this in everything that we do in class, whether it's actual programming or something that is not programming, but a strategy. But there's a computational thinking involved there, right? How you can take an advantage and turn it, with limitations and turn it to our advantage. So 2's complement is worth knowing. So arrange a time. And because if it's, I don't know, we'll see. If I have time over the weekend, I'm happy to, but by Friday is the deadline for the quiz. You got to do the quiz by Friday. So try to make a time with these guys, understand it, and do it. There are going to be questions about 2's complement in the data representation quiz. So totally understand that. But base conversions, you're good now, right? And there are a couple of big point questions in the midterm, in the data representation quiz to do with base 27.
So you said the quiz is due tomorrow, Friday?
It is, isn't it? According to Canvas, anyway. That's what I said it to.
I thought it was Sunday, but I could be
Yeah,
wrong.
was it set to Sunday? I forget.
That's what I saw as well.
So what does it say now?
It says April 14th, so that would
Is it
be
Sunday?
Sunday, yeah.
Yeah, all right. So you got time until Sunday. Even so, we can, take it, take the opportunity, Josh and Caitlin, if they're free for a half hour or an hour, and if they can basically give you a really quick tutorial. And if possible, just record it too and share it on the channel for other people to benefit from. Yeah, it'll be like a mini podcast where you're actually teaching a concept. It's a very simple concept, but it's like a bullet, informational bullet, and saying, hey, you know what? Here's a 15-minute blurb from 2 students trying to teach what 2's complement from the perspective of 10's complement for negative numbers. That's it, right? And that's a very nice little podcast-like thing that other 2A students can just watch like 5 minutes before the exam, something like that. So yeah, okay, and it'll be a good practice for you too, to try and explain these concepts in general. So please, take a crack at doing these things, and if everybody's happy with what we've done so far, we can call it a day. And what time is it now? It is 7:59. Again, thank you.
Someone has a question.
Yeah, Josh, go ahead.
Yeah, Manya, or how you say your name, your hand was up.
Manya, you have a question?
We can't hear you.
Can't hear you, Manya. Manya, are you working on the audio?
I think she's typing it in the chat.
Oh, I see. Don't think my mic is working. Yeah, all right, type it in chat and then we'll see if we can respond. Does anybody else have any questions in the meanwhile? While Manya is typing her question.
I'll say, are the floating point numbers covered on the quiz?
Yeah, totally. You got to learn about
Yeah, because
floating.
I remember last time, like the floating point numbers, they were like some of the hardest questions, at least to me, on the quiz.
Yeah.
So, double check the floating point numbers.
We didn't cover that.
Sometimes.
Yeah, why don't you make a time, guys? Okay, so because it's only due on Sunday, make a time with Josh and Caitlin to talk about floating point notation also, right? 2's complement. I just had a question about what is it that Manya is asking? Why
we separated octal binary digits into groups of 3? Well, if you remember back to when Richard was sharing the screen, every single octal digit has a one-to-one equivalent of 3 binary digits. So it's like if you can kind of memorize it a little bit, like you see an octal number and you can instantly convert it into the 3 binary digits. So it's just more convenient that way to think of it in those groups of 3.
Yeah, because with 3 binary digits, you can go from 000, that is 0, to 111, which is 7. So so you have 8 combinations, 2 to the 3 combinations, right? So 0 to, and so that is the reason. And so we get 3 chunks of 3 bits, then you can map each of those to an octal digit. I hope that answers your question. Yeah, Manya? Good. Fantastic. Right. If you guys don't have any more questions, thank you all, especially everybody who coded today, right? And Wendy, and yeah, who else? You know, and yeah, then Taksuin also was not, you know, you actually did have answers and all, and so on and so forth. Yeah. And who else was who else coded? Ava coded. Ava coded. Someone coded before you. Ava, who was coding before you?
That was me, probably.
Who? Richard?
Yeah, I think so.
So it was Richard and then Ava today. I see. Yeah, and then I remember what happened after that. That's great. Thank you all so much for your time and patience. And yeah, you have.
Sorry, then. Yeah, I just have a really quick question about the live coding notes that we take. So if you remember, I did a live coding, or not quite coding, but I did one last class and I took notes on it. And the extra credit was to figure out why the division conversion works, right?
Yeah, and you did post it too, right? Did you post it?
No, that I wanted to ask also which flare I should post it on, and if there's like a certain format or.
Oh, I think you can just post under I think there's something called concepts or building blocks.
Concepts. Okay.
Yeah.
And in the future, would you like us to share all of these notes every time, or?
Yeah.
Oh, okay.
In fact, you know, what we can do is if it is possible, condense the notes into just one graphic.
Yes.
I think students have done that in the past, and then funny enough, there's one student, Omar Rivera, several quarters ago. He produced a graphic using colors and arrows and find cool things about this base conversion, and he posted it. And 3 quarters later, someone else picked it up and said, "Hey, I found this really cool thing on Reddit," and there was a student who made this, and it was basically, you know, distilled out of the notes we created in class. Fantastic. And students are actually producing these incredible artworks, essentially, encapsulating the, you know, essential bits of these things. So yeah, by all means, share your notes. You know, it can just be a dump of the PDF and share it too. That's okay. But you can exercise your artistic judgment and
all right, thank you.
Thank you. Yeah. Anything else?
Yeah. How do we schedule an appointment with Josh?
You just reach out to him by email or direct message on Reddit. So many.
Yeah, my Reddit username is Josh_G369. And I also posted on Reddit, welcome to CS2A. You just click that post, click my username, and then send me a DM.
Okay, sounds good. Thanks.
Yeah. And also Caitlin, right? You can reach Caitlin also like that. In fact, you can reach any user in here, but certainly Josh and we're all on standby. And as the class progresses, you'll find that, you know, certain people will be done with certain topics earlier than others, right? And that tends to move, right? Some groups will move ahead in this topic and some groups will move ahead in that topic. So the people who know a certain thing will be different each time. All you need to do is just get in touch with them directly, right? And the best thing is to do is just make a post, you know, a random post in Reddit saying, I don't know who to reach, but I need to know this. And the one who knows this will just automatically reach out to you. You don't have to worry about, oh, I need to find this person. You just make a post in a Reddit and Josh or me or someone will just reach out to you. How about that? Yeah, because that's easier, isn't it?
Great.
Yeah. So don't worry about doing the DMs and all. It's a pain. Just make a post and we'll get in touch with you. And play this game, okay? Play this game, Grady, because they are collecting data. And it is a great deal of fun, I think, right? You can actually, you know, set up a team too. You can say 2 people against 2 people and play it. and it'll be a great deal of fun. All right. Thank you all so much. And Caitlin is actually part of that research project, right? And you can actually talk to her about it too. I'll see you guys on Tuesday. Did you guys, was this useful? Was this class useful? Despite the fact that we didn't cover those two topics, but you got to do that on your own, right? A two's complement and floating point. You got to do that on your own, but you got resources here, right? So you got to do that. Was this class still useful? Was this week fully useful? You got to write a reflection. Yeah, thank you, Ava, right? But Ava coded today. But yeah, I want to see some more thumbs up from people who didn't code, okay? Saying, hey, I didn't code, but I still found it useful. Give me some thumbs up there so I know that we're going in the right direction. Okay, Jesus, all right, Yan, Chanyu, all right, okay, yeah, all right, great, okay, so there's a whole bunch of people. Excellent. Hey, Ian, was this useful?
Yeah. It's a lot of new information for me, so I kind of have to process it and try to even understand which questions to ask.
Okay. All right, but you should ask, okay? Please do ask. Anything that is unclear, you have until the weekend, Sunday. Just ask in the forums and someone will reach out to you and help you out, okay?
Thank you.
And also Manya and Sophia, all of you guys should just feel free to ask your questions and get, clarification. All right, have a fantastic weekend, and I will look forward to seeing you all on Tuesday. Yes? Okay, all right, see you later. Bye.
Hi, Professor. I just want to ask, like, how when should we post the week reflection?
Before Sunday.
Before Sunday. Okay, so it could be any day of the week. Whenever you have something to write, right? And you can only post once.
You can post multiple times, but typically I only take the one post that, yeah.
Oh, okay, yeah.
And cool. It doesn't have to be long. It just needs to have something interesting. That's all.
Yeah.
Awesome. All right. I'll see you later. Bye.
Have a good night, Professor.
Bye, you too. Bye.